Beep. Okie dokie. Solving equations. Answer the following questions. Why should the equations x minus 1 multiplied by x plus 3 equals 17 plus x and x minus 1 times x plus 3 equals x plus 17 have the same solution? Well, first off, we're crooked. And now we're not even in focus. Let's try again. Okay. Because what property we use? We use the commutative property. The commutative property does not change the integrity of the problem. Here, x minus 1 times x plus 3, 17 plus x plus 3, x minus 1. So again, this is the commutative property. Once again, it's not of addition, it's of multiplication. We know the commutative property does not change the integrity of the problem. X minus 1 times x plus 3 equals 17 plus x. Uh-oh. Well, this is a new one. So what happens when we do this? Well, we added the same thing to both sides. We can add the same thing to both sides. Remember, it's like a scale. This didn't change the integrity of the problem. If I've got 7 pounds on this side and x on this side, and I add 500 to this and 500 to this, it should stay the same, okay? That doesn't change the integrity of the problem. Same deal with the last one. I'm going to bring it up. Do you think these equations are the same? 17 plus x. In this case, what are we doing? Well, we're multiplying. Multiplying by 3 to both sides does not change the problem. They are still equivalent. Okay, when we do something to both sides, it does not change the integrity of the problem. The key to this whole lesson is understanding that the commutative property, the associative property, the distributive property, the additive equality, so additive equality means if I add to this side, I add the same thing to this side. The multiplicative equality, if I multiply to both sides the same thing, those are all the same. So what can I do here? It says use the commutative property, write an equation that has the same solution. Okay? Well, I'm going to change this up and I'm going to say negative 3x plus x squared plus 4 equals x plus 7 times 5 times x minus 12. So I use the commutative property twice. Addition, multiplication. Could you have done something different? Sure. Use the associative property to show that it has the same solution set. Okay? So I'm going to say x squared plus negative 3x plus 4. So all I did was group those equals, and here I'm going to say, okay, x plus 7, x minus 12, and I'm putting those in brackets because the brackets show that that's the grouping multiplied by 5. So I'm doing that first. That doesn't change it. Does this reasoning apply to the distributive property as well? Yes. I can change the order of anything in the parentheses as long as I still distribute to everything in the parentheses. The key is distributing to the entire thing. Again, the understanding for this is to make sure that the commutative property, the distributive property, and the associative property do not change the problem. Okay? It does not change the problem. That's all we're trying to figure out. So, let's go. No, I don't want to do it. I knew I didn't want to do it, but I saw it and then I was like, maybe, and then I decided not to. Solve for r. Well, this should be pretty easy. We're going to solve for r. There's several different ways to do it, so I'm going to rewrite this out. I've got 3 divided by 2r equals 1/4. You could cross multiply, or you can isolate the variable. So I'm going to multiply both sides by 2r. Those divide out, that leaves me 3 equals 2/4 r. So now I have 3 equals 1/2 r because 2/4 simplifies. Multiply both sides by 2, r equals 6. All we're doing is solving an equation. If I wanted that as a solution set, I'd put something like that. If I wanted to graph it, I'd have 0, I'd have 6. There's my answer. This one I subtract 5. That leaves me s squared equals 25. Take the square root of both sides. S equals positive and negative 5. Solution set. Negative 5, 5. Okay. Solve for y. Again, you know how to solve equations. Subtract 4y from both sides. That leaves me y minus 8 equals negative 3. Add 8. Y equals 5. So these are all equations that we should be getting comfortable doing. Okay, in our prep work, we did quite a few equations that were very basic that you should understand and still remember. Okay, because we're going to keep building on that. So what's the key to equations? And I said this day one. After your very first time watching the videos, we did something very similar to this. Without you even knowing it, and actually, let me phrase that, without me even knowing it, I didn't know this example existed in our book, or our book. Consider the equation. Look at all, there's 4 different ways to start the problem. I want you to choose 2 of them and do this. Solve this problem and choose one of the 2 groups and actually see what happens. So if I do this, subtract 3x from both sides, okay? And then I would work the problem out. If I chose this one, subtract 8x from both sides. Okay, subtract 8x. Does that change the problem? It's not going to change the answer, but it will change the method in which I do the problem. Remember, algebra is not a box. We are able to think outside the box and start to get different ideas. Okay, so the key here is commutative property does not change at all the equation. The distributive property does not change the equation. The associative property does not change the equation. Multiplicative equality and additive equality does not change the equation. It will keep it the same. This was a shorter lesson, but still important. Still going to have a lot of practice with this one. Happy whatever day it is.